Yes. Hi everyone. I am SS Kiran. I would like to explain about experiment of the transistor acts as a switch. Okay. By using Proteus software. Right. First, create one folder in any drive or any folder. Okay. Observe here. How can I create a new folder? Take new folder. Then write switch. Folder name is switch or transistor switch, your wish, as your requirement. Okay. Now double click on this Proteus 8 professional. Double click on this Proteus 8 professional. Then click on no need to additional existing one. Okay. Then click new project here. Just observe here closely. You can zoom in of video new project. Okay. After this new project, you must select the respective folder by using this button, browse button, desktop. Okay, in the desktop, EDC experiments, go to switch, then select folder, switch, double click, then select folder. And here, file name is very important. Before dot, you can write transistor transistor underscore switch, transistor underscore switch. Transistor spelling is wrong. Yes. Okay, transistor underscore switch. Okay, then very simple, click on next, finish. That's it. Okay, this is our designing window, schematic capture window. You can zoom little bit, zoom, then components are very visible. Okay, now required components are function generator as per the requirement. Okay, and then LED, resistors, and transistors. Okay, go to the circuit diagram. This is the circuit diagram. Based on this circuit diagram, you can design as it is. Okay, now go to this Proteus file. The first of all, this is BC107 and two resistors. Okay. Then okay, BC107 is our transistor, required transistor. Then select, then click OK, then keep here as shown like this. Okay, then resistor is also very important component. RESISTOR, resistor. Resistor is also very important component in this experiment. RES device. Go with this one. You can place here based on our requirement. We can keep at one is the base side, other one is the at collector side, other one is the collector side. Okay, you can rotate this one by using a right click and rotate like this, and scroll slowly, drag by using this mouse left click option. Next, one more resistor at collector side. Yes, keep here. This is also very important resistor, and rotate like this. Right click and rotate by using this option or any R also. Okay, that's all. Next, one more important component, that is LED. I will go with LED, yellow, BIBY. Your wish. Various types of LEDs are available. Then click OK. Then keep here LED. That's it. Okay. See, this is the circuit diagram. Very simple. Just you can connect a switch also. Sample switch. SWITCH switch. This is active switch. Yes, switch. Now keep here. Switch here. Okay, switch. Now next thing is the V source, input voltage. V source. This is also very important. V source or battery or RPS. You may call anyone. No problem. This is V source. You can connect this V source. Right. Or RPS, regulated power supply. Then one more V source. This V source you can keep here. Okay. Right. Now take a ground symbol. This is the terminal mode. Yes, it the complete left side terminal mode is there. I will show you once again terminal mode. Then go to ground. Keep here ground here. Ground is very important. One more ground is also keep here. Okay, here the components are, just scroll down, components, just scroll down. And this transistor also better scroll down. Right now, placement is ready. Okay, now you can start. All components are placed as per the circuit diagram. Now start wiring or start connecting. This plus is connected to this switch. Another end is connected to resistor. This resistor, another end is connected to the base. This collector is connected to this 10 kilo ohms as per the circuit diagram. Okay, actually 1 kilo ohm. I will change the values also. No problem. And this is connected to here. Okay, now this collector. Okay, 1 second. Now this collector, and this one is connected to ground. Okay, and this negative is connected to the ground. Then beautification is very important while connecting the circuit. This is also one of the important parameter. Then ground button you can drag just above. Right now, this is connected to collector. Okay. Now this resistor is connected to anode. Other one is the cathode. Now here interesting thing is this is where then you click escape. No problem. Right now just you escape or cancel button. Okay. This voltage symbol is little bit top of the screen. Now go to ground and ground creep here. Here this is the ground. Okay. Then okay, now connected to here. Next here, this wire it may be connected to ground. Better you can delete this wire. Now you can drag this resistor little bit down. Now start connecting like this. Now start connecting like this. 1 second, I will show you. This is plus zoom in, zoom in, zoom in. This is extra wire. Okay, this is also extra wire. Just right click and delete. Here I am doing some beautification arrangements. Okay, this is fine, and now I will go with like this. Now it is okay. Right. Now this is circuit diagram. As per the circuit diagram, I have connect. If you want input voltage, you can connect voltmeter in input side. If you want output voltage, you can connect voltmeter at output side. So this is base. You can add text also. This is text graphic mode. This is you can write base. Okay, right. This is base. You can write here emitter. By using this text mode option also you can write the values. Here you can write collector, no problem, collector. Then okay, just you can drag these names just where use this option. Just drag this one. You can adjust the names as observe here. This emitter you can place here. This base is also okay. Now here one more interesting thing is virtual instruments mode for observing the voltage. So click this virtual instruments mode. Okay, then keep here the voltmeter. No, no, sorry, here oscilloscope. Then click on a DC voltmeter. Click this DC voltmeter and keep here. That's all. And take one another voltmeter. Before connecting this voltmeter, just rearrange these things, because beautification is very important. Okay, beautification is very important. Just rearrange the components. Okay, just rearrange the components. That's all. Okay, that now it is fine. Otherwise, just you can brings into little bit left side. That is fine. Now take another voltmeter, DC voltmeter. Keep here. Okay, it will take some time, no problem. Then click this DC voltmeter and keep here, or else you can save this experiment and start wiring. And this is start wiring as per the circuit diagram and start wiring. Now come back to circuit diagram. Another voltmeter is also connected, collector and emitter across. This is DC ammeter, this is DC voltmeter. I can place this DC ohm meter. Okay, now this copy copy the clip card and uh, here paste from the clip card, then place here. Sometimes it is not visible. You can also doing like this. Okay, then start wiring like this across VCU voltage. Fine. Now change the values as per circuit diagram. Both are 1 kilo ohms. Input voltage is 5 volts and VCC is also 5 volts. Now change the values by clicking the value, then 1 kilo ohm, then click enter. Here this is also 1 kilo ohm. That is fine. Okay. Actually, this is 11 kilo ohms, not 11 kilo ohms, 1 kilo ohm, then okay. Now here, not better you can go with 100 ohms. You will get some good glow. 100 kilo ohms, 100 ohms, not kilo ohms, ohms, 100 ohms. Now here input voltage is 5 volts. Okay. Then VCC is 5 volts. VCC is also 5 volts. You can write here, this is VCC, the name is VCC. You can write here like this, VCC, that is good. Capital small c, small c. Okay, no problem, VCC. Circuit is ready as per circuit diagram. Just observe it. Circuit is ready, switch is ready, everything is ready. Okay, now start executing in a simple manner. This is the start button. This is the start button, simulation button. Complete left corner. See here, complete left corner. This is the simulation button. Click on this simulation button like this. Yes, now LED start glowing. LED start glowing. There is some drops are there here. Some drops are there. That is called 0.55 volts. No issue. Here LED is. I am not giving any input supply. Here I am not giving any input supply. But LED is start glowing. Okay. Now here I will give input voltage. Input voltage just by controlling the switch here. Just click here. Okay, now here LED is off. If I give input, LED is off. If I not give any input like this, now LED start glowing. Okay, this is the very important experiment. If you give input 0, output is 1. If you give input 1 like this, you input 1 like this, you will get output as 0. By the way, we can explain this experiment with the help of function generator and CRO. Then it will be very easy. Stop simulating. Okay, then remove this switch, right? Remove this switch and 1 second. Some message is there. Sorry for the inconvenience. Then delete this voltage source. Okay, now delete this one also, delete this one, and delete. You can keep resistor, no problem. Okay, delete this one also, no problem, no issue, and delete this one. Okay, this voltmeter, and delete this voltmeter. Okay. Now here I will do connect some signal generator. See, this is our signal generator. Signal generator. Once if I keep signal generator, 1 second. Okay, there will be a small issue here. No problem. Components are not highlighted. No problem. Then first stop this simulation. Then again go to Proteus 8 Professional. You can open the recent folders. No problem. Just click on this recent folder. Sometimes some components will be hanged. Okay, then slowly zoom in like this, zoom in like this. That's it. Now go to instruments mode, then go to signal generator, then keep here. Now the components, some instruments are visible. Okay, then go to oscilloscope, then keep here oscilloscope. This is the oscilloscope. Same, very simple. This negative is connected to the ground. Okay, this negative is connected to the ground. Input signal is given to this 1 kilo ohm. The channel 1. See how I am connecting this channel 1 So beautification is very important. Channel A, here channel A is input signal. Now I will go to output signal connected to channel C. Okay, that's all. Here I have given the signal. Here I will apply the square wave now. Now anyway, circuit is ready. This is some different circuit. Okay, then you can click this start button. You can simulate this button in a simple manner. Okay, I will check whether the circuit is okay or not. Yes, circuit is 100% okay. Now start simulating. You will get the waveform. Before getting the waveform, so first you can adjust the values here. First you can adjust the values in a simple manner. Okay. First of all, I will give 5 volts. I will give 5 volts like this. Uh, this is 5 volts. Okay, this is 5 volts. Now the signal is waveform is square wave. The signal is square wave. That's fine. Then next here I will go to keep here 1. Okay, change the time period accordingly. Time period I will go with 1 kilohertz. 1 kilohertz. Okay, then it is also very important. 1 kilohertz. Okay, yes, fine. Then in this one, I can change the channel C knobs also like this. Now change the amplitude. You will get accurate values. See the beauty of the output. For common emitter, there will be some phase shift. If I give input 0, I will get output 1. If I give input 1, output is 0. See here, this input is 1, output is 0. Here input is 0, output is 1. Channel A is the input, channel C is the output. Okay. This is a experiment for transistor, how acts as a switch. Very simple experiment, easy experiment. You can also implement Proteus software. Okay, thank you so much. Keep watching. I will update more videos by using this Proteus software. Thank you. Okay, bye.